Page 15 in your 1F packet, the problem of the day. So we're still working on percents, and we have to read the directions very carefully. Write an algebraic equation, so yes, we need an equal symbol, that can be used to get the answer in, again, one step. So finding the total cost of an item. So if the item costs C, $30, $40, $50, $60, $70. Example 1, the item costs C, the discount is 30%, the sales tax is 8%, and the markup is 75%. Oh my gosh, finding the total cost. So this you're going to have to use method 2. So the discount, 100 minus the 30%, that'll give you that you're going to pay 70%. The tax, 100 plus 8%, you're going to pay 108%. The markup also gets added, 100 plus 75%. You're going to pay 175% more than that cost. So the total T equals 70% as a decimal, 7/10. So you see it right there. 108% as a decimal, 1 8/100ths. 175% as a decimal, 1 75/100ths. So just say something was $100. You're going to pay 70% of that $100. You're going to pay tax $8 on that $100, and it was increased to not being $100, but being 175% of that, or $175. So it's increased by a markup, it's increased by a tax, but it's decreased by a discount. This is finding total, so you do have to do method 2, which is adding or subtracting the amount from 100. So the original price of a microphone is M. The discount was 42%, and the tax is 6%. Well, discount gets subtracted. So 100 minus 42 would give you 58%, and the tax, 100 plus 6, would be 106%. So the microphone times 58% times 106% would give you the total cost. So the total cost would equal 58%, change it to the decimal, 58/100ths, times, now you're going to go and get tax on it, which would be 106%, which would be 1 6/100ths, times whatever the microphone costs. So you're going to get a discount, and then you have to pay tax. That's how you find the total. Find the discount, and then tax the item. That's what it's going to cost you. So total equals 58/100ths times 1 6/100ths times the cost of the microphone, M. The original price of a lizard, you're now at a pet store, it's discounted 40%. Well, if it's 40% off, I'm going to pay 60%. That's the way you have to think about this. And if the tax is 6% more, tax is always added on, I'm going to pay 100 plus that 6%. I'm going to pay 106%. So the lizard, which is $39.99, to get the total cost to me if I go buy him at the pet store, it would be that $39.99 times 6/10, 60% of it, and then times 1 6/100ths for the tax. So I would get it at 60% of that $39.99. And yes, I have to pay all 100% of that discounted price plus 6% more tax. And again, I could have done 6/10 times 1 6/100ths and then put the price of the lizard at the end. It doesn't really matter because multiplying is commutative. So number 13, the cost of a hat, H. The markup is 10%, the discount is 40%, and the tax is 5%. So the hat cost a company to make it, and they marked it up only by 10%. So 100 markup plus 10% would give me 110%. Now they put it on sale, so 100 minus 40% off. That means I'm paying 60%. And yes, the tax always gets added on, so 100 plus 5, I'm going to pay 105%. Oops, don't put a decimal in there yet. 105%. So my hat, the total cost to me would be that markup, 1 10/100ths, or 1 1/10, times my discount. I'm going to pay 60% of it, 60/100ths, or 6/10ths. I might take those zeros off, just because you don't really need them. So 1 1/10, 110%, 6/10ths, or I'm going to pay 60%. Then I'm going to pay tax of 5 more %, 1 500ths, times the cost of my H hat. Cost of a computer game, $4.99. It's marked up by 40%, discounted by 55%, and taxed by 1%. So 100 plus my 40 gives me 140%. My discount is 55% off, so I'm going to pay 45%. And it's taxed by only 1%. That's nice. So 100 plus that 1%. I'm only going to pay 1 penny more for every dollar, 101%. So the total cost of the computer game, I'm going to pay 1 4/10 for the markup, 45/100ths for the discount, and 1 100th for the tax, times that $4.99. Explain the difference between an expression and an equation. An expression does not have an equal sign. So therefore, it's not a full mathematical thought. But an equation has an equal sign. Equal symbol. And is a full mathematical thought. It's like a full sentence in English, an equation. Oh, that's not even close. Mathematical thought. It's like a full sentence in English, an equation. An expression is like a phrase in English. It's very much related. So next page, a real world percent problem. Peter's allowance is the same every month. Each month, Peter spends $114 and saves the rest. He saves $432 in a year. What percent of his allowance does Peter save every month? He saves $432 a year. Well, there's 12 months in a year. So first of all, I got to figure out how much he saves in a month. So if I take my $432 and I divide it by 12, I'll get each month. I got to get the rate that he saves each month. Well, that's $36 per month. So he saves $36, but he spends $114. So I have to add my 114 plus my 36 to get that he has a total of 150 coming in. Must be his total allowance. I need to know the total to get the percent, to figure out the F to D to P. What percent? Oh, excuse me. So he saves $36 out of his $150. This is the part, that's what he saves. This is the whole, the total, the original. So he saves for every $150, he saves $36. When I divide that, I'm going to get 24 hundredths. Change it to a percent by multiplying by 100, sliding 2 to the right. I get 24%. So what percent of his allowance does Peter save? Peter saves 24% of his allowance. Lots of steps involved in that one. First of all, I had to figure out how much he saves every month. Then I had to get his total for the month, because that's not the total, that's just what he spends. And then finding the part of his savings over his total to get the correct percent. And if you're not sure of that, make sure you ask me questions tomorrow in class. So number 4, Cheryl used 40% of her money to buy a dress and a fifth of the remainder to buy a pair of shoes. She then donated $60 to charity and had $132 left. How much money did Cheryl have at first? Oh my gosh. Cheryl used 40% of her money to buy a dress. And then a fifth of the remainder, well, if she used 40%, that means her remainder is 60%, I know that, to buy a pair of shoes. She then donated $60 to charity and had $132 left. Cheryl used 40% of her money to buy a dress and a fifth of the remainder to buy a pair of shoes. I think I'm going to bar model this. 40% was the dress. 60% was her remainder. She used a fifth of that, so this part's cut into 5, basically. She used 1/5 of that to buy a pair of shoes, which means she has 4/5 left. So if I figure out 4/5 of that 60%, of what number? 4/5 of 60% of what number, which I'm going to call x. I got to find the original amount, which is x. And then I subtract $60, I should have $132 left. Oh my gosh, this is a hard question. 4/5 of 6/10, because I'm going to change 60% to 6/10. Oh, 4 and 10 have something in common, not 5 and 6. So you get 12/25. 12/25 of what number minus 60 is going to give me 132? Well, if I add 60 to both sides to solve the adding part of this, I get 12/25 of what number is going to give me 192. Wow, this is definitely like a bonus question. Dividing by 12/25 on both sides is like multiplying by the multiplicative inverse, 25/12. Oh, I would never ask you one this hard. This is a very, very hard question. You get that x equals 400. Because 12 goes into 192 16 times. 12 times 16 is 192, and 16 times 25 is 400. Wow, 400. She used 40% of her money to buy a dress, and then had 60% left. So she had at first $400. The answer is 400. Ooh, we're never going to have a question that hard. It would be a bonus question. But that's a really big question. You could bar model that and figure that out. And that's it for today.